Okay, so in this problem here, we have Yenny owns a small factory that makes shirts, and she wants to model the relationship with the daily cost to manufacture the shirts versus the number of shirts, N. And so the cost is S. And she believes the model is going to be this kind of a power model. She knows that even if you're making no shirts, the daily cost of running the factory is 1,000. So the cost will never be below that. That is going to be the horizontal asymptote. So the value of C is going to be 1,000. She then collects data and estimates the following values. And I've taken them and already put them into my calculator here, as you can see. And to determine the linear equation of the natural logarithm of S minus C against ln. So we want this to be our y and this to be our x to get a linear equation. So we need to create this. So in order to do so, I'm going to carefully keep track of my things. In L3, let's make this, we're going to do the natural logarithm of S, which is L2, which is L2 minus 1,000. And I'm going to put that into L3. And so I know this here is L3. And then in L4, I'm going to do the natural logarithm of L1. And so now this is L4. So this is L1, L2, trying to keep track of it. And so now I want to do a linear regression of these two. And when I do that, I go stats. I'm going to do a linear regression. And I know my X list is going to be L4. L4. And my Y list is going to be L3. And let's put it into Y1. Okay. And those are my values. I'm going to do it again, and I'm going to check out my R value. So I'm going to turn my statistics diagnostic on. And let's take a look at what the R value is just for interest's sake. So now when I do my calculations, do it here again. Okay, so I can see the R value is 0.99. It fits it really well. And so do a linear regression, determine linear equation, is that. So I can say that ln S minus C is equal to my slope is 0.75. ln N plus 3.899. If I steal this, I can keep those values here handy. Plot the data points of L of these two. So if I go to my statistics, I'm going to take a look at them. Let's go, my X list is L4. So put in L4. My Y list is L3. L3. And then I'm going to go zoom statistics, which is number 9. I can see that. I can plot it. Find the values of B and ln A using linear regression. I guess that's what I did up here. And so the B value, they're talking about this model here. Okay, so find the values of B and ln A. So if I consider what's going on here, if I take this scenario and I do some algebra on here, I know that this is ln S minus C. I'm going to raise this to the power of E. So E to this power is equal to E to 0.75 ln plus 3.99. And my penmanship's not very good today. So then I have S minus C, which is 1,000, I remember, is equal to, well, if I do this, I know this is E. I'm going to take the 0.75, raise it to the power of ln N 0.75 times E to the 3.99. And so S minus 1,000 is equal, now these cancel out, so I'm getting N to 0.75 times ln A, well, I'm going to get, let's just do that, I'm going to get e to the 3.9889, which is basically 54 times 54. So my model is S is equal to 54 n to the 0.75 plus 1,000. And so if I find the values for B, well, B is 0.753. This is the B value. And ln A, if I do the natural logarithm of 54, that is going to be the 3.9. If I do that value here, this is this value here is the natural logarithm of A is what they're asking for. So this value is ln A, and 0.75 is the B. Even though they're different on here, it is all with regards to these values in the model A and B. Hence, find a model for the cost of producing the shirts. I've done that. That's the model. Jenny would like to produce 500 shirts a day. Use the model from part E to estimate the total daily cost. Well, I know then that 54 E to the 0.753. Oh, not E. I'm sorry, not E. That should be 500. Oh, let me start that again. 500 times, oh my goodness, try that one more time. 54 times n is 500 to the power of 0.753 plus 1,000. That's going to be the cost of 500 shirts. So I have S at 500. That will be 6,820 dollars to three significant figures. Describe the dangers of using this model to estimate the cost of producing 500 a day. Well, the dangers are, or we are extrapolating. Do we know if this power regression will continue and to a certain point? If it will continue this pattern, it's hard to say. Then finally, describe how you would enter the data using your GDC to find the model using the power regression function. So the power regression function does not deal with the asymptote. So we're going to have to go to my statistics. I'm going to go to edit. I'm going to delete these here. Clear, enter, clear, and enter. And what I'm going to do is I'm going to actually subtract 1,000 from all of these. So I'm going to go L2, oops, L2 minus 1,000. So now everything's 1,000 less. And so that is going to be my Y value. L3 is going to be Y. L1 will be X. And if I go to my power regression now, which is letter A, I know my X list is L1. And my Y list is it's L3 already, I know that. And I'll put this into Y2. I can see that my values are the same, but I have to add 1,000 to it. And so because my equation is the same, it's going to be the same as it is in part E. Hope that helps.